What does the state of a system really mean in physics? The concept sounds simple but is quite interesting, so I decided to dive into it a bit. A system's state is basically a complete snapshot of its physical condition at one moment in time. In classical physics, defining this state is straightforward. We describe various things such as where an object is and how fast it's moving, including its position and momentum. With these values, Newton's law lets us predict how the system has evolved and how it will behave next. Any uncertainty here comes from our measurements, not from nature itself. But when we zoom down to the atomic scale, this classical picture stops working. Electrons don't follow neat planet like orbits. Quantum mechanics gives us a new way to describe a state, a wave like probability based picture of where a particle might be. In atoms, electrons occupy specific energy levels. These levels aren't continuous, but they come in discrete steps. And at this scale, we cannot know a particle's exact position and exact momentum at the same time. This is fundamental limit of nature. At the quantum scale, the state of system doesn't just tell us what particles do. It reveals behavior that classical physics can't explain at all, like particles tunneling through barriers that should block them. Understanding these quantum states isn't just a scientific curiosity, it is the foundation of many technologies we use every day. Semiconductors rely on quantum states to control how electricity flows. Camera sensors detect light because electrons shift between energy levels. Lasers work by preparing atoms in precise quantum states. MRI machines read the magnetic states of atomic nuclei, and quantum computers process information by manipulating quantum states directly. So, the meaning of state shifts from a perfectly predictable picture in classical physics to a probability driven, wave based description in quantum physics. Understanding this transition reveals how the invisible rules of nature shape the technology we rely on every day. For more such content, follow Curious because we believe curiosity changes everything.